Hi there, Mr. Boer here with week 6, our last week of online learning. And what we're going to look at this week is chemical reactions. And this is found chapter 11 if you still have your book. If not, I included the PowerPoints, videos, a lot of stuff that you can look at for reference. So if we look at chemical reactions, the first thing was something we talked about way back in first semester was that all chemical reactions have two parts to them. They have reactants that turn into products. And it ends up becoming an equation, just like in math, so that you have your reactants equaling your products. And we talked about that when we were doing law of conservation of mass and how the masses of each side have to match up. And we're using grams, and how many grams of this plus how many grams of that, has to equal a certain product, just like in math. Well, the same thing is true of the atoms themselves. The number and types of atoms as the reactants have to equal the number and types of atoms as the products. So not only do you have the actual masses in grams, you have the types of atoms and the number of atoms having to equal each other too. Now, in order to be able to do this, I know there's a couple of things that go in the book in how to relate the equation itself into a few different forms. So you can put it in sentence form, where you can just write them all out in sentences. You can put them into what's a word equation, where you include some symbols. If you look at this one on here, copper reacts with chlorine. If you can just say copper plus chlorine and use that symbol in there instead of writing all the extra words. Or you can actually end up using the actual symbols themselves. Instead of writing out the word chlorine, you can use Cl as a symbol. So you got the full sentence form, you get the word equation, then you get the chemical equations that have everything. So there's really 3 different ways that you can write this stuff. And in order to go from word to formula, you have to go back to chapter 9 2 weeks ago, and we talked about nomenclature, which is going to be, how to name different formulas. So if I gave you the sentence form, you'd have to change all the names into their chemical formulas in order to be able to do the reactions that we're talking about. Now, a few of the symbols they use, as you see here, the arrow is a lot of times used to be equal. It's kind of the equal sign in a math equation. Plus sign is and. These things, S, G, and L, that they will put after the substance isn't in every equation, but when it is used, it's there to tell you what state of matter it's in. So solid, gas, and liquid. If we keep going, AQ, which we learned when we were talking about the naming of acids, means dissolved in water. Doesn't have to be an acid, but a lot of times the acids are dissolved in water. So if you see AQ, it's still salt. In that case, NaCl. AQ, it's just salt water. If you put an arrow up, it means that a product was a gas when it was produced. So when you remember a product on the right side of the equation, if it's got an up sign, it means that gas was produced in the reaction. If you got an arrow going down, that means that it is a solid has been produced. And a few other ones you won't see as often are these arrows going back and forth, which means it's a reversible reaction. So the reactants become the products, and then the products can also react to become the reactants again. And then these symbols you won't probably see in any of your homework, but if you go on in chemistry, this is basically meaning that there is some type of thing needed for the reaction to take place, some type of energy, heat. If a catalyst is used to speed up the reaction, you'd have to put what the catalyst is used. So in this case, platinum was used to make the reaction speed up. What we want to get to is being able to write skeleton equations. Now, skeleton equation uses, like I said, the symbols and all of those, the chemical symbols and the symbols for plus, where we end up not having to use all the words. But the thing with a skeleton equation is it doesn't have to satisfy the law of conservation of mass. It's simply there to be a recipe. So like if we were doing a recipe and we were saying, okay, I want to make chocolate chip cookies, you got to have chocolate chips, you have to have flour, you have to have eggs. Just listing what the ingredients are is what a skeleton equation is. Now, if I include how many of each type, that becomes a balanced equation. Like if I said I need 2 eggs in this recipe to make something, that becomes not a skeleton equation, but a balanced equation. So we start off with just skeleton equations, and then we have to be able to balance them. So that's where we'll pick up on part 2.